Hello everyone. So in the previous question, we discussed how to make a priority queue using heap. In this question, it's not really a question, it's a concept. So in this video, we'll be studying the concept of how a priority queue can support the interfaces of comparable and comparator. And this is a very interesting concept to learn, especially if you like to reverse engineer things down to their core. So say we have an array right here, and if we were to use a priority queue, and print this array in say ascending order, what we will do is a pretty simple loop, as we have been doing in the previous questions. And here we simply print whatever we remove from a priority queue. So we know that whatever we remove from the priority queue has to be the smallest possible element in the queue at that moment. Let's try to run this and see what we get. All right, we have to add our elements to the priority queue first. First, I add my element to the priority queue. And now I print it. Mind you, this is going to be a very lengthy video because the concept is very detailed. So I need your complete attention for the entire span of it. And you can see that with our priority queue, we are printing all of our elements in sorted order, increasing order, for this example. Now, the question that we did, write priority queue using heap, it was doing basically the same thing. But since we are using the inbuilt priority queue right here, I say that it should be able to support classes as well. I mean, these are just integers. I want to sort complete classes. Say I have a class here. I have a class student. The student has three attributes, say roll number, height, weight. I have a constructor to define these values for me. I have roll number, height, and weight. Now, our class is almost complete. That's basically our student class. Now, what I want to do is that I want to sort the student class according to the roll number. Now, this simple priority queue might not be able to do the trick for us. And what we'll have to do is that we'll have to define something known as a comparable interface. But before that, let's actually add some elements inside our priority queue. Say we don't need integers here. I'm going to add some elements of the attribute of the class student. pq.add new student. I'll make a new object and add it. This will have different values, 10, 180, and 85, some arbitrary values just to prove a point. Let's have 4 5 more values. I have 2, I could have 12. Let's have some variation in the height as well. And same goes for the weight. Let's have something different. Now, say I had to, let's say I want to print all my results in sorting in ascending order with respect to my roll number. Let's try to run this and see what we get as an output. Data type was missing. That wasn't intentional. Let's make our class static. Mind you, this is a very lengthy code. It will have a lot of errors, but in those errors, we'll see that, well, the solution is hidden. So, incompatible types. Okay, a priority queue should be of the type student. We're basically converting an entire priority queue to a generic class. Now, let's see what we have right here. Okay. All right. Now, this is an error that we can work something on. Now, we have the class student, which cannot be cast to comparable. Those are a lot of words which might not make a lot of sense to us. It says that priority queue, we should sift up the comparable priority queue, etc., etc., etc. What does this actually mean? It sounds like a lot of gibberish at the moment, but at the end of this video, I promise you, you will have a better understanding of how to, well, deal with this error and, of course, the entire concept. For that, let me head back to this particular question. Now, I'm assuming you've done this question before and the code is basically imprinted in your mind. Then and only then will you be able to understand the rest of the video. So, say we have this upify function. So basically, on adding an element, after adding an element, we upify it to its correct position in the priority queue. We see that there is a function called isSmaller, which compares the child to its parent. Let's go to isSmaller. We see that we are using this operation, a is less than b. For integers, since we are dealing with the type integer here, for integers, as you can see, our list of integer. For integers, it does not matter. I mean, this is a perfectly fine solution if we're just comparing integers. But for entire classes, such as the student class that we have, it is a problem because, well, the class that is a program, it does not know that it does not know on which attribute, on the basis of which attribute should we actually sort the entire priority queue. We don't know that. So to solve that problem, what we're going to do, let me just I think you're confused at this moment. So what I'm going to do, I'm going to write a few things down so that you can keep track. Just yeah, okay. First, we have an inbuilt priority queue. Now, this inbuilt priority queue, it has to support sorting between classes as well, right? If I want to print with respect to the roll number, I should be able to do so. I'm sure you've seen programs that do so. So, inbuilt priority queue should be able to implement a PPFI function that we just saw. We were able to do it for integers, but inbuilt priority queue should be able to implement a PPFI for any generic classes. Any generic classes. But at the moment, we do not know what attribute should the class use for comparison. So for that, what we're going to do is that we're going to implement an interface. We're going to implement an interface known as comparable. You may ask what is an interface and what is comparable. So I have explained the concept of interfaces in very fine detail in the video. I'll just write the name down here very quickly. Iterable and iterator. It is a very detailed video which has a lot of details about interfaces as well. For now, I'll just explain it in very brief. So interface is basically a contract of a function, or I should say that it's a signature of a function. It's a skeleton, even better, a skeleton of a function. Skeleton of a function or should I say skeleton of a class. Skeleton of a class. Now the skeleton of a class has functions without bodies. So you may ask that, I mean, there's no point if the function does not have a body, right? There is no logic inside that function. What are we going to use it for? So in actuality, there are classes, right? The classes such as the student class that we have, classes that implement these interfaces. Classes that implement these interfaces. Basically, they are responsible for providing the body of these functions that are inside these interfaces. Provide body of functions. Now you may ask, how are these interfaces relevant here? That is because, well, we are going to use this one interface known as comparable. We're going to use an interface called comparable. Say, let me just implement it for a bit, and then we can go back to the theory portion. I don't want to bore you. So, like I said, this class will implement an interface called comparable, which will be of the type, well, our current class student. That's what we basically have to do. Now, this comparable interface has a function known as compare to. Comparable only has one function, that is compare to. Now, this compare to is of the return type integer, and basically what it helps us with is sorting of this class inside a priority queue or in any other way, just sorting in general, based on a certain attribute. Say, I want to sort with respect to the roll numbers. I'll say return this dot roll number minus other dot roll number. Now, I know you just got confused. Where did this other come from? What is this other representing? Basically, in a PVFI, as you were comparing parent index, to the child index, we're basically doing the same thing. This dot roll number will represent the roll number that is here. Other dot roll number is the object that we pass, object of type student, that we pass to this compare to function to compare it to the value that we have in this particular class represented by this. I suggest you brush up on the concepts of this because they will be used throughout this video. So now, the way this sorting is done is of the form that if this, okay, let me just right. Now we are in compare to, and I wrote down some weird statement, which was this dot roll number minus other, let's just call it O dot roll number. Basically, I'm comparing the two objects, the roll numbers inside the two objects. I say that if my current roll number is smaller, if my for this, if this is smaller than other dot roll number, we are going to return a negative value. I mean, we're returning an integer, right? So this dot roll number, which will be an integer, minus other dot roll number, this will return a negative value for us. And what does this mean? This means that when we compare the two, our roll number right here is smaller. That means it should be pushed up the chain, right? Because we want the list in an ascending order. This roll number should be shifted up and this other roll number should be shifted down. So we return a negative value to denote that. If our t happens to be equal to other, we return a 0, that is both of them are of equal standing. Then if t is greater than other, let's call it OT to not confuse it with 0, we return a positive value saying that our current roll number is actually greater than this other roll number that we are comparing it to. So that means that we have to shift this roll number down the chain. That's basically what we are trying to implement here. And what we expect out of this is to get a list of, well, elements that are sorted in ascending order with respect to the roll number. Now trying to implement this here, what do we get? Say we have all of these things with us right here. Let's try to run this. Not find symbol, other, of course. Now, it printed some gibberish that we cannot understand. In this gibberish is actually, well, our object that we're supposed to get in order. So to actually print this in a way that is readable, we override the toString function. That is public string. This will return a string to string. That's how you basically override a function in Java. There's an inbuilt function called toString which does the job for us, but we want it to do a job in another way. So to do this, we have, I'll return my roll number, this dot roll number. Before that, I will actually print roll number. Plus height. I need your complete attention. Please do not sleep off while watching this video, because I know it can be lengthy and it can be quite difficult to understand. In fact, it took me 3 tries to get through it, and then I grasped the concept. I hope you can do it in 1 or 2 tries. At least that's my attempt. So we get our height as this dot height. Similarly, we have weight plus weight. I think we implemented this correctly. So let's see what we get. Now, look at this very carefully. The output is sorted with respect to the roll number. We have roll number 2, 10, 12, 17, so on and so forth. And then we have 18. So we got our output the way we intended it to. Now, how can we actually implement this in a way that we implemented the previous question, that was write priority queue using heap? I say that this works perfectly for integers. Now I want to use this very logic for all classes, not just the integer class. I want to use it for all classes. I want to make this as generic as possible. For that, I say that why don't we try to write some pseudo code here. Of course, I'll revert this back, so don't get confused. I say that I want to typecast whatever value I have, integer or some other class, or typecast it to a comparable type. Comparable parent is equal to typecasting here. And here we had our original value, that is data dot get the parent index for my parent. For my child, I'll simply change the variables here. Now we have in a smaller function. Let's remove it for now. I say that in place of this, we can write child dot compare to parent. Now we had already discussed what this function will do for us. It will give us a lot of scenarios. So let's see that if our child is smaller than our parent, it will return a negative value. Because we want to sort it in ascending order. That's what we planned. This will deal with the child and other will be the parent. we'll find out that the child is actually smaller than the parent. That means child is smaller than the parent. That means that the child should be shifted up. And for shifting up, we have the swap function, which we implemented previously. That is, we swap, if we have a child, this is our child, this is our parent. We compare the two, we find out that the child is smaller. So the child should be somewhere up in the priority queue, right? Because we have to extract it before the larger value. So this will move up. The PPI will work now. Swap PI. That's basically what we're trying to implement here, but this is not the actual code for it. I'm just trying to explain the concept I'm trying to get at. Let's revert this back. Let's not play with these values for a moment. We will do the typecasting and everything that comes with it. For now, let it stay as it is. Now, before we move forward, I think we can do a bit of revision on what we just covered so that everything is clear to everyone. Now we have our compare to class. There is a child dot compare to, writing it in short, parent. To summarize it, we have the fact that if child dot roll number is smaller than our parent dot roll number, we find out that our returned value is negative. If we return the value as negative, that means that the child is smaller, right? The child will be smaller, parent will be larger, the return value will be negative, quite naturally, my bad. And if that is the case, we have to shift the child up the priority queue, the heap, so to speak. And this will be done by swapping, as we have discussed in the previous question. So I suggest you watch it again, as it has been covered in very fine detail. And this will basically sort our output in ascending order, which we have just observed. Now, for doing the same thing in descending order, what we do is that we, instead of doing this minus other, we do other dot roll number minus this dot roll number. Say this, we have child as our this and parent as our other. The tables will be turned here, and this time we see that the output will actually be in descending order. To understand it even better, I'll reiterate it in the form of, well, a more organized form. Let's have some scenarios. We have the scenario 1 where we have this minus other. This is the way we're comparing our objects. In this case, we have, say, child dot roll number is less than parent dot roll number. In this case, of course, and there is the other case of other minus this. Now, if the child is smaller, then the returned value will be negative, right? It will be negative. That means that the child is smaller than parent, which we've already determined, and that means that the child will shift up. Child will be shift up, which implies that the smaller element will be found on top. Child will be shifted up because it is smaller, so the smaller element will be found on top, which is what the priority queue returns. In the other scenario, we have, well, other minus this, in which case the parent happens to be bigger than the child. So we get, in this case, let's consider the scenario that the child is greater than the parent. For this case, we'll get the value as negative because other is the parent, which is smaller. The smaller value minus the bigger value gives us negative output. That means that the parent has to be, that means that the child has to be moved up. Since this is our implementation and we are swapping on this particular condition, that means that the child has to be shifted up. Child shifted up. But this time the child is larger, so the larger element will be found on top. And this will give us our output in descending order. Let's try to implement that really quickly. So we already had this particular class with us. If we did other.roll number minus this dot roll number, as I explained, we should get our output in descending order. We see that the roll numbers are in descending order. And that's basically what we have to implement with this particular logic. We've done this using inbuilt Java libraries. Now let's do it in the logic that we built in the previous question. For that, firstly, we'll have to make our classes as generic. We have an integer class here. We don't want to be restricted to an integer class. I say that let's make it generic. Again, generic classes have been explained in detail in the video Write HashMap. I suggest you watch that video to get a better idea of generic classes in case you are not familiar with them. So we convert this integer to a generic class, so it can be done for any class now, especially our student class that we will be implementing right now. We have our upheapify. We have is smaller. Is smaller will be changed in a bit, but we'll get to that. Then there is a lot of comparisons that needs to be done. For example, in remove, the type that will be returned is a generic type. It will return null in case we don't find a value. Since we're talking about objects here, null. Now, coming to is smaller, this a less than b, was actually not very good for us because it was just comparing integers. It won't work with our compare to function. So what we're going to do is that we're going to change it in a way that is, well, more suitable for us, which is what I explained when I was trying to typecast the values that I had here into the comparable class. Now, for that, we need to make a few changes to our code. I say that I just want to pass indexes here for a reason, don't worry. Not doing any of this arbitrarily. In a smaller, I have to change everything to the comparable class. So I say that comparable first we're sending the child, right? Okay, so comparable child is equal to data dot get a. This will be of type comparable. Same goes for parent. Now I check if my child dot compare to parent is less than 0, that means the child is smaller, return 2. Else return false. This can be written in a more generic manner, but for the sake of this example, I'll explain it using these variables, child and parent. Now we just need to bring our compare to class from the previous class. I say that I will steal my classes that I just made, which I worked very hard on. I'll simply bring this here with me and replace my main class with it. Like my main function with it. Now we need to make another change, that is this will be of a generic type, so let's just specify that here. Incompatible types. Of course, there'll be errors because we still need to deal with integers and convert them to a general class. We have line number 15. Data dot get I. Okay. All right. Of course. So we'll change the type here to T. And let's see what we have. Same problem in down heapify because. All right. So let's change this to li first because we just changed the signature of the nature of the swap function. We're just sending indexes now. All right, let's see what we get. Line 72, same error. Data.al add, which will be of the type T, a generic type, which could be string, boolean, integer, whatever you want, which is causing an error in quite a few places. So we'll just deal with them one by one. I'm just converting integer to a generic class here. These are very small errors. And now, wrong answer, we don't care about it. We are testing it on our own input. So we see that our input was whatever it was earlier, and now things are in descending order according to roll number. That is basically what we wished to implement in the first place. Trying to do this in ascending order, I'll just reverse what I was doing in compare to. I have my student class here. I'll simply put this dot roll number here, and things would be in ascending order now. There we go. That's basically what we wish to do in the first place. Now, what this code is doing is that it's basically writing a priority queue using heap, not just for integers, which we did in the previous question. It can now do so for any sort of class. If I want to change this entire thing for my height instead of roll number, I can do that too. Feel free to try it out yourself. Now, I say that a student could possibly want to compare their attributes, well, based on more than one attribute. Say here we're comparing things based on the roll number. Let's go back to our original class. Actually, that will be easier to explain. We're comparing things based on the roll number. I say that I want to explain the differences in an order based on the height and the weight. And for doing that for multiple attributes, well, we can't do everything right here. For that, we need another implementation of an interface. That interface is called a comparator. So I write static class student height comparator. This comparator basically implements the student class. Sorry, this implements the comparator of the student class. Now, this job is pretty simple, and that job is to use its own function compare. We use that function compare, and we simply before what we were doing, that we were passing the other object with us, and we were comparing it to this attributes. Here what we'll do is that we'll simply pass both the objects directly. Now, if we have to compare the height, we'll say that in ascending order, say we have s1 dot height minus s2 dot height. Now, we can do the same for our weight. To implement this here, what we'll do is that we'll pass a new student height comparator, and let's see what we get as our output. It's not able to find a symbol because I messed up the spelling. I think it's correct now. Let's see what we get. All right. As you can see, our output is being printed with our height in ascending order. It has overridden what we were doing as a default case for the roll number. It is now printing with respect to the height now because we've passed this comparator to our priority queue. Doing the same thing for our weight. For our weight, now you can see that the weight is also in ascending order now, but the other values are jumbled up. Now we have to implement this exact thing in our priority queue, which we wrote which we improved as compared to the previous question. And now that we have a generic class, let's implement a comparator in it. Now to implement this, let's bring our comparators to this particular question right here. Let's keep them in this place. All right, looks good. Now the actual implementation. What we're going to do is that we're going to make another constructor now. Keep up, this is almost over. We have another constructor, and in this constructor, what we're going to do, say we have a comparator here. Comparator. In our default case, where we haven't passed a comparator, the comp will be null. In case we have, say we have our comparator, then this dot comp is equal to comp, the value that we have passed. Now we'll have to make some changes to our smaller function, in the sense that where we are applying this compare to, what we'll do is that we'll make two cases. In the first case, say we don't have a comparator with us, that is if comp is equal to null, I will do the job that I was doing, no change there. Otherwise, if I have a comparator, I'm going to do something a little differently. That is, I'm going to not do the typecasting. Instead, I'll just take my child and parent as the generic values that they are. Let's remove that. Now, here I will simply write compare. This comparator will be comparing it for us. So com.compare, we have the child with our parent. So, well, if this is our output, you return true, otherwise you return false. Let's see how well we do. I'm guessing we must have some errors to resolve. We don't. Okay, that's great. So you can see that we've done the default case here, which is that we will be sorting everything according to the roll number. But now, like we did previously, if we add a comparator, say according to height, if we pass this, let's see what we get as our output. Everything is sorted according to height. The height is in increasing order. Similarly, just for the sake of it, I'll show you the concept of doing it with respect to weight. Now things are sorted according to the weight in increasing order. That's basically how you implement comparators. That's basically how you override the default case, which can be retrieved in this manner, which you already ran, but let's just do it for the sake of it. And things are in roll number order wise again. And now that we have our answer with us, we know how to implement everything. what we can do is just summarize what we learned in this lesson. So basically, we saw comparable, we saw comparator, we saw priority queue, in Java, and with that we also saw the way to implement this priority queue on our own in a generic manner. Then for comparable, we saw a function called compare2, and in compare2 we can get our ascending order if we do our comparison as this minus other. Rewind and revise, and well, feel free to explain the reason to yourself on why that is. And for descending order, we do other minus this. Then for our comparator, well, we have a function called compare, in which we pass object 1 and object 2, and then we simply do our comparison in it and return the value. And this comparator can well be passed on as an argument to our priority queue in case we want to sort our values according to a different attribute as compared to the default attribute. That's basically all that we've learned. And well, with that, this topic seems to have come to an end. And thank you so much for watching. Hope it was useful to you. And well, all said and done, feel free to like, subscribe, and share this video. And once again, thank you so much for watching.